Hey everyone, in this video I want to show you one of the dangerous parts of using AI, and that is when they hallucinate with an authoritative confidence. So they make up stuff and lie right into your face as if they have every fact figured out and researched. Okay, this is the only dangerous part that I can see, and it can easily get you off track. So here I show you two examples that I found recently dealing with AI, and I wanted to share with you. And it typically does not happen recently with simple stuff. Okay, I've seen in the past people asking AI, hey, why is the earth hotter than the sun? And AI started making up stuff. It's not like that anymore. It's really smarter. It has improved. It has learned a lot. But still, when it comes to the challenging parts and the parts that it is lacking data and missing data, they don't activate this up. They have not activated this option in it that, hey, AI, if you don't have training data in the vicinity of this kind of question, just say I don't know. That is the dangerous part. When AI doesn't say I don't know, it just makes up something and beautifully hallucinate it and give it to you as if it knows it. So here, the first example, in solid mechanics, there are three parameters: Young modulus, shear modulus, and Poisson's ratio, E, G, and nu. And these three are related to each other, right? G is E over 2 times 1 plus nu. And the thing is, to prove that, there are not too many sources on the internet. If you watched my channel in this video here, that I said two important proofs of solid mechanics. Let me show you that. So here, in this here, I showed that y e equals 2 times g, 2g times 1 plus nu. Okay, but apparently ChatGPT did not have access to this. And again, there are not too many websites that prove that. So ChatGPT, I asked it, hey, show the relation between them. And the interesting thing is, when it didn't have it, it starts from some point that relation is already known and then comes back to it. So it starts from somewhere that this relation is established. For instance, E equals 2g times 1 plus nu. Then it goes all the way through a cycle and then comes back here and says, well, now we have shown that g equals E times 2 times 1 plus nu. Okay? So it assumes that the thing exists, it assumes it's right, and then comes back and show it's right. It's clearly a cycle that is not correct. You cannot assume something is right if you want to prove it. But here, it really did that. And it went through lots of things. So here, you see, it goes through the Hooke's law, and for a normal and shear strain. And then, look, it goes through bulk modulus here. It says, hey, we know that bulk modulus is that. Well, we don't. The fact that bulk modulus is this because this relation exists. Look here, it says, we know bulk modulus is this. Another important relation is this one. And then conclusion, this. Look, so it assumes this is correct and then jumps into this one. And then, look, I said, I did not see any proof. What is bulk modulus? You're bringing another variable into the problem without answering directly my question. You're bringing this k somewhere here that is related to E and nu and so on, and then comes back. Nobody asked about k. I want to know why this equality is true in the first place. Okay, so it says, oh, yeah, you're right. Let's do a formal proof. And now look again. It starts with the definition of bulk modulus and then shows that for the hydrostatic pressure case, then it found the strain, and then it found the volumetric strain, and then it found that K is this. So first it showed what is K and where does K come from. Now look at here. Again, it goes to look at the derivation. It says, we know that K is this, okay? And then, look again, G equals this, so it goes back. So you see, it brings K. It has nothing to do with this question. It just brings something extra that has nothing to do with the problem and starts from the fact and goes back to the fact. And it says, hey, I did not see how bulk modulus related to the other two parameters. And again, it tries to go through, look here. It starts from something and then goes back and it tries to show. And look here, I picked on it and said, hey, when did you establish this? That's what you need to prove, right? I said, when did you get that? This is correct. This is what you need to prove to me. And then again, look, it tried so many different things, just spitting around the bush, and could never, ever show why this is the proof. I mean, if you want, go through this video and you see here, I proved that using an element with two sides equal and the change in this 45-degree angle and the strain along this diagonal. There is a lot of proof going on before I show you that the relation between G, E, and nu is established. And I did not come up with that proof myself. I got it from a source that I mentioned it. Okay, so here, you see, you have to go through lots of things before you can show that we calculated the strain on the diagonal from two different ways and show that they are equal. Then we got to this point. So it's not like as simple as assuming that is correct and then going and showing it's correct. So clearly it's making up stuff. You cannot do that and you cannot show it in your assignment if your assignment is to show that. Another case that is more interesting, I say write for me a code using MATLAB functions that detects any arbitrary edge shape, basically inside another shape. When I was making my video on a generalized Hoff transform, I asked MATLAB to see what it can do. And it first tried to do it with the normalized cross correlation. And I said, well, the method has to be robust against rotation and scaling. And then first try to do it with surf, and you know surf has limitations too. So I say, okay, no, I want you to write it with generalized Hoff transform for me. And this is the code that it wrote for me. And look at this interesting part. Here it is using this function called vision.generalizeHoff, right? So it is using this function, and when it reads the template image and the target image, it is using this function to detect and to show the results. So I copy pasted this code here into MATLAB and I just ran it with one template and one target that I have. And guess what? It says, hey, what is this? I am able to resolve vision generalized Hoff because there is no such function in MATLAB. If you just go and search MATLAB documentation, you should not be able to find this function, okay? So it just made up something again. It assumed that this function does exist, and look here, and guess what? It doesn't. And it did it another time to me. It made up some function called ellipse, which finds ellipses in an image. And that function also didn't exist. I don't have it here, but I can find it and show you. So it easily lies into your face with a basically straight face itself, or easily beating around the bush and not showing anything. This is the part that you need to have the knowledge. If something is not working, then it cannot do it. And remember that really the power of AI is only related to the sources that it has, okay? Because you can always look at it like an interpolation or extrapolation. If I have data here and I have data here, but I have nothing here in the middle, and I'm asking it to fill in the blanks for me here by doing interpolation, or out here in the extrapolation, if you don't have any data near this, the problem is it is trying to come up with some function that fills in this gap, okay, and then kind of answers the question. The problem is that function might not be correct at all, okay, or it might not exist in the first place. So it just assumes something here, while really it could be something completely different, okay? So that is the problem that it has. And filling the gaps, while it should have thresholds. Say, hey, when you're asking for this point for a huge offset on either side of it, I do not have any training data. So when my offset for training data, epsilon, is bigger than so much, correct? Then I should not give an answer to you. And I simply should say, I do not know. But AI is not designed like that. It is designed to fill in the gaps and finding functions that might not even exist. And that could sometimes be very dangerous, those hallucinations, because it tells you that with some authority, confidence, instead of just simply admitting it doesn't know it. So I want you to be a little bit careful when you are using it, although it's amazing. I use it myself a lot, but I have been sufficiently trained on the topics that I ask for, maybe some code or something, that if it doesn't work, I know it immediately and I can fix it. Otherwise, I would not trust it. And again, when it doesn't do the job like this, or it come up with something that doesn't work at all, that is better. At least you run the code, MATLAB gives you an error, and you know it did something wrong. But sometimes it might make something that looks really nice, and in the surface it is working, but it doesn't. It generates false results. That is even more dangerous. It's like a runtime error versus a syntax error. So be please very careful when using any AI platform, whether ChatGPT or Copilot or I don't know, Gemini, DeepSeek, or anything. And although they are getting better and better, this danger always exists. They cannot innovate. Okay, they call it generative and they say, yeah, they can innovate. No, really, the best they can do is as good as the data we provide them and how much data we have. And as you know, many people, big names in AI, they are saying that they have exhausted most of the data on the internet or all of it. And so now they have to create artificial data to train the networks. So we are reaching, to my belief, maybe I'm totally wrong, we are reaching kind of the limits of how much AI can do. Okay, because we don't have more data unless we make more. But please be careful. Thank you so much for your attention. I'll see you in the next lecture.